Hello everyone. Today we'll start a new chapter, continuity and differentiability. So today we'll be covering continuity. Okay. So to understand this concept of continuity, you should be very clear about the topic limits which we studied in 11th standard. Okay. So first of all we'll see what is a continuous function, what is continuity. Okay. So a real valued function f is said to be continuous at a point a if limit x tends to a minus of fx is equals to limit x tends to a plus of fx is equals to f of a. Now what is this? Okay, so a function is said to be a continuous function if first of all the limit exists. What is this? This is the left hand limit of the function. We are finding limit of the function at a point a. Okay, so this x tends to a minus, this is showing the left hand limit of this function fx, right? And this x tends to a plus of fx is showing right hand limit of this function. So function is continuous if the left hand limit is equal to right hand limit is equal to the value of that function at this point a. Okay, so if these three are equal, we'll say that the function is continuous at this point a. Okay, the point at which we are finding the limit and at which we are finding the value of that function. Okay, alright, so if this LHL is equal to RHL, we saw this thing last year also. If LHL is equals to RHL, so that means the limit of that function exists. Okay, so the first important criteria is that the limit of that function, it should exist. Okay, and that should be equals to the value of that function at that point. If these three are equal, then only the function will be continuous. Okay, we'll understand this thing using one example. Okay, discuss the continuity of function f defined by this. Okay, so now we have to discuss the continuity of this function fx. Okay, so this function fx is defined by this. Now value of fx is x plus 2 if x is less than or equal to 1. It is x minus 2 if x is more than 1, greater than 1. Okay, so now if we have to find, like if we have to check whether this function is continuous or not, what we have to do is we have to find its left hand limit and right hand limit first. Okay, then we have to find the value of the function at this point 1. Then if all three of them are equal, we'll say that the function is continuous. If they are not equal, we'll just simply say that they are the function is not continuous. Okay, so let us find left hand limit first. Left hand limit of this function, limit x tends to 1 minus. Why 1 minus we have taken? Because obviously we'll find the limit of this function at this point 1, although it was not mentioned in the question at which point you have to find the limit or at which point we have to discuss the continuity, but it is very obvious from this function by the definition of this function. Okay, why? Because this function is defined for this point 1 only. Okay, so we'll discuss the continuity at this point 1. Alright, so we'll find the limit, left hand limit at 1, and that is coming out to be how much? 3. Okay, in this case for left hand limit we'll consider this function x plus 2, right, because this is less than 1. So your left hand limit is coming 3. Alright, similarly you'll find RHL, right hand limit. So right hand limit, for right hand limit we'll use this function, this value of function x minus 2. Okay, so limit x tends to 1 plus of x minus 2, we'll put this 1 over here. So what are we getting? We are getting minus 1. So since the left hand limit and the right hand limits, they are not equal, so what you can do is you can leave a question over here only. Okay, there's no need to find the value of the function at this point 1. Okay, if the limit is not existing, so that means the function is not continuous only. Okay, there's no need to solve it further. So you can directly write, since the limit is not existing, so the function is not continuous. Okay, and just leave your question over here. So this function fx was not continuous. Okay, Alright, next we'll see algebra of continuous functions. Okay, now suppose we have two functions f and g, both of them they are real valued function and both of them are continuous at a point c. Okay, f and g, these two are two real valued function and they are continuous at a real number c. Okay, so if we add those two functions, so the addition of those two functions, whatever we'll get, so that function will also be continuous at the same point c. Okay, in the same way, like if we subtract those two functions and then whatever we'll get, that function will be continuous at the same point c. Similarly, for multiplication and for division, if we multiply two continuous functions, so the resulting function will also be continuous at that same point c. Similarly, if we divide two continuous functions, so the resulting function will also be continuous at this point c. Okay, so for continuity, basically you'll have such type of sum where we have to discuss the continuity of the function, or they can give you like this. For example, this question, they'll mention that the function is already continuous. They'll say that the function is continuous, and then we have to find one unknown value. For example, in this question, it was not given whether the function was continuous or not. We have to find whether the function is continuous or not, right? We had to check the continuity of this function. But in some questions, they'll mention that the function is continuous. For example, in this, find the relationship between a and b so that the function f defined by this is continuous at x equals to 3. So in this question, what they have given is that this function is continuous. We know that this function is continuous. So there's no need to like show that LHS is equal to RHS is equals to FA. We know that they are already equal. Okay, what we have to do is we have to find the relationship between a and b. You can see a and b, these are a part of the function only. Okay, okay, so we have to find the relationship between a and b so that this function is continuous at this point 3. All right, so since it is given that the function is continuous, okay, so let's see, it was given that the function is continuous at x is equals to 3. So that means the left hand limit, this is left hand limit, is equals to right hand limit is equals to the value of that function at that particular point. Okay, so left hand limit is what? Limit x tends to 3 minus of fx, that is equals to how much? For left hand limit, we'll use the first part of the function, that was ax plus 1. Okay, so now we'll put value of this x, we'll put 3 in place of x, so we'll get 3a plus 1. Similarly, you can find right hand limit also. This is the right hand limit, limit x tends to 3 plus of fx is equals to, in this case we'll use the second part of the function bx plus 3. Okay, now if we put 3 in place of x, we'll get 3b plus 3. Okay, alright, so now since it was given that the function is continuous, so that means the left hand limit of the function will be equal to the right hand limit, right? So left hand limit is 3a plus 1, right hand limit is 3b plus 3. Now just put them equal and then solve it. So what are we getting? We are getting a minus b is equals to 2 upon 3. So we got the relationship between a and b. The question was what should be the relationship between a and b, right? So the relationship is this, a minus b is equals to 2 upon 3. So the difference between a and b should be 2 upon 3. So if the difference between a and b is 2 upon 3, then only the function given will be continuous. Okay, so this is how you can solve such type of questions. Alright, so now you should be able to solve questions on continuity. I hope you understood this lecture, and still if you have any doubt, you can leave a comment. Okay, thank you so much for watching.